So today I'm going to be reviewing exercises. I had an agent do all of them. Then I just prompt. But then I had to do a second pass. I used an agent and LLMs, the Gemini, Grok, and ChatGPT, to review each one. And then I created other two lists to. So I think I did 3 passes. So the first one, I had it like probably multiple different agents create all the exercises. Then I did a second pass to see which ones could have mistakes using the 3 different LLMs. Then I created, or actually I used an agent, I think, on the first pass to see the mistakes. Then I did another pass with LLMs to create this other list here to review. So I found the highest priority ones to review first, and that's what I'm going to be doing now. I already did 2 of them. And the goal is to go very slow and understand everything the most in-depth way I can. At least for these ones, I think that once I finish these ones, then I'm gonna try to go very fast. Or even after the first, or even after the like a couple of more, like 3 or 4 more, probably gonna try to go very fast, so I don't get stuck on this part for too long. So I was gonna do a rustlings thing where I took rustlings and tried to change the code, but then I figured out that, or I decided that it's just too overly complicated, I think. So I decided that it's best to create this simple folder with exercise and one with the solution. The idea is that you run a script there, and then the script basically uses Cargo Watch, I think, to kind of launch the exercise file, and then you have to basically reconstruct or try to fix the implementation. And then obviously the solution is what you compare against. So I'm going to be reviewing the solutions now. I'm going to review this red-black tree. It's the first time that I've seen this. I've never saw this before. So I have no idea what kind of error is going to be. But I'm pretty sure that there are errors, since I already see that there are problems with the compilation. I'm not really sure, actually. This is something that I was just thinking about now that is kind of confusing. I'm not sure if I'm supposed to have compilation errors on the exercise file or not. I'm just gonna prompt the 3 different website LLMs, read the response, and read the implementation, try to figure out what needs to change. Actually, to create the list, I still not sure. I don't know if I'm gonna add more because obviously I'm not really sure how effective this is gonna be. But the idea is to have a training ritual I can do every day, like a baseline, and then beyond that, I study libraries and try to build things. So I think initially spend more time on the exercises, and then once I'm good enough, then I start to switch more to studying stuff and building things. So the way that I decided to build this is basically try to build exercises around the fundamental data structures. Because I was thinking I want to train the stuff that I'm gonna use the most to build things. So I compiled the list from all the Tria website LLMs, to create the like hierarchy of the exercises. And then I came up with this, but it's also like not enough, I think, because the solutions are more for pedagogical reasons. So a lot of them they use pointers instead of using the vectors, and I think in practice I'm probably not gonna. It's not gonna be the same thing applying them. So I think ideally I would have a couple more exercises to just train the main methods of the built-in data types like vector, string, and stuff like that. But I'm not really sure if it's worth it or not to do this. So I guess we'll see. And it's gonna take some time to finish reviewing everything. I have to copy on the other ones. So if I understand correctly, the box is kind of like I think it's a unique pointer from C++. I'm not 100% sure if it's a unique pointer or pair pointer or something like that. think an option is something you can use to determine whether a value is sum or null, because Rust doesn't have the null value. So you wrap the type you want on this option, and it allows you to check whether or not it's null. Yeah, it's null or it's some value. So here is a unique pointer, I think, of a type. Yeah, a pointer that uniquely owns shape allocation. So the first question that I have is why doesn't it specify the color here on the new? As far as I understand, so far from what I've seen, Rust doesn't have a constructor, but the new implementation is usually supposed to be what the constructor would be. And the way that it works is that usually you define a struct. So in C++, you have classes, and then each class is an object that has data and has functions inside of it. But in Rust, they separate the data from the functions. So the objects in C++ is also the same way when it comes to structs. The structs and classes are basically the same thing, but structs are public by default, everything inside of the struct. And the class, everything is private by default, but they are basically the same thing. But in Rust, they separate the struct, which is the data, from the implementation, which is the functions. And this allows more composition, I think, because it allows you to create multiple different ways from the data to be transformed from one place to the other, basically. So and as far as I understand, on the red black tree, the roots node is always supposed to be black. So I don't know why they don't initialize this as black here. And it's also, I remember, I think I already tried to build or work with existing red black trees and read a book about this. But I remember that it's very confusing and very hard to make it work. I think this one's gonna be very challenging to figure out what is going on. And this is kind of the problem with doing this with agents and LLMs, is that you never know for sure if they are hallucinating or saying the truth. So like I have to do this pass here to figure out or to review the class manually, the solution manually, because then if I don't, I'm gonna be training against something that doesn't make sense. And then I'm gonna like internalize the wrong patterns. That's the issue. I assume this is from. This is another thing that is kind of. It's very difficult to understand. It's probably the thing that's it has been the hardest to understand in Rust, which is the concept of ownership and the borrow checker, and like how these classes change this. Like in Rust, you only have one thing. You only have one owner. Things can only have one owner, and it's not very clear to me exactly what an owner is, but I think it's basically like the first thing that initializes, or whatever is the last thing that points to the thing. That makes sense. Like if you initialize a variable to 5, for example, like let x equals 5, then the x would be the owner of that 5. But then if you reassign the x, it's gonna shadow the first one. So it's gonna be the owner of something else. But I'm not really sure. And there's all kinds of rules. It's very confusing to understand. But one of the things that is confusing about has to do with ref cell, RC, and boxes. Is the concept of interior mutability. So I think something that is not the owner of something can't change the value. But the exception is these types. They allow you to change, but I'm not really sure about it either. So here, I think is getting the reference, the box. Or should a node probably. Option T, so the T would be the box in this case, I think. And I think I'm just gonna ask these questions. Actually, I'm not really sure like why there's a T here. Here's the type of the value. Let's see the errors as well. I think I should probably go like linearly or from top to bottom first. Then once I roughly understand how it works, then I'll look into the error and the warning. These are something that like it's becoming easier to understand now, but it was confusing at the beginning, which is the where syntax. And it basically is just something you use to constrain the type of the generics. The generic is kind of like you're saying that any type can go through that space. Is a function is like a highway. So, or like a bridge would be an easier way to imagine, I think. So when you have the T, you're saying that basically any car, anything that can move, can go through the bridge. But then the where is kind of like specifying that only cars can go through the bridge, or only trucks or stuff, or anything you put inside of the clause. So it basically constricts the what kinds of things can be used in the generics. In some situations, I think it makes sense. For example, here, where the T comes from the whole thing, from the implementation. But then for that specific function, you constrain the type. So kind of like the entire implementation is like multiple different lanes on a highway, and then the where clause would be like one of the lanes that only trucks can go through, for example. That's how it works. I think the clone is a macro that they put there, and it's probably a macro that allows you to clone the class as a SAS. Because again, I think that's this notion of, I think other languages, they clone the objects by default when you don't use references, but then Rust doesn't because of the concept of ownership, probably. So when you make the variable equal, it's gonna drop the first one, I think. Not sure, actually. But then I am pretty sure that you call .clone on whatever you want to copy, and then it allows you to duplicate the thing instead of moving the value. I think that's how it works. So I think that this is a macro or a trait that you use with the plus thing there, probably. Or maybe it's just, yeah, so use the macro here, to derive. So I think that this thing here is a macro in Rust, and what macros are basically is a way that Rust allows you to extend the language, basically. So what this derive macro does is implements all these other traits for this enum here. So it's basically saying, is adding functionality to the enum. And so I'm not really sure if I understand what the error is. By this bound timing. Consider further restricting the permutive trait clone. Well, so it's saying that I should implement this on the implement here. Actual add. Sure if I is complaining here. So the plus sign is also confusing, but it's basically the same, a similar logic to the where. But then this one is like a union between types. So it allows you to extend the type. So again, in the highway example, if art was a car, for example, and clone was a truck, then you're basically saying that either one of them can be passed through the highway. I'm gonna go sequentially, then I'll look into the error, try to compile again, change some things, try to compile. Then I'll look into the ChatGPT ChatGPT's response. I think I'm just gonna spend a bunch of time asking questions around this, like fundamental things. So the first one I was this here. I think that what this is doing is obviously getting the reference, training a value that it is pointing to the reference of the root. And it's gonna loop through this until it reaches a null value. I think if there's only one null, it's gonna hit right away, I think. It's just gonna return false. So it's basically an algorithm to check whether or not an element is inside of the node. Is inside of the tree. Not that complicated, I think. This may be something that I can ask as well, like this comparison here. Because if the element is t, then how does it work? Obviously, if it is an integer or a float or something like that, then it makes sense to compare as two values. But then what if the t is something else? It's not very clear, like whether or not that this is problematic. But I guess here is forcing the t to be either one of these things here, or in the original one would be this ORD. I don't understand this ORD. I think it's that trait that allows you to implement some like ordering algorithms, but I don't understand how it works very well. Yeah, so I think that basically what this is saying is that since this t here is going to be this ORD type, then it guarantees basically that you're going to be able to compare. So it doesn't matter what is the specific type, because the fact that it's constrained by to at least implement ORD, then it means that it has to. And I'm guessing that the like built-in types probably implement ORD with the derive macro as well. So most likely, I think most of the time it's probably going to be like either probably an integer or a float, but not sure if strings as well. I think it would make sense, obviously, to have a string in some cases as the element. So I guess string probably implements the clone as well. Not really sure though. So it's kind of easy to just basically traversing. I think this is doing a binary search using the tree nodes to get log n time. From what I was seeing as well, it seems that Rust uses the API under the hood. So they're basically using the same memory allocation. And they use it through C, but I'm not really sure. It's just one function that I saw there. With this mem and the pointers, the low level. Maybe this is something else that I have to. Why does the call take here? So I think that this is base case, obviously. If this is no, so if the root is no, just gonna return that the elements you're inserting is gonna become the root. Because then it's gonna hit this condition here. And it's gonna return this new box. And then it changes the color here to make sure that the root is always black. Kinda easy to understand. And again, comparing, probably gonna call recurse. So if the element is smaller than no. So small values go to the left, then bigger values go to the right until you hit the exact one, I think. Recursion is super difficult to understand because it forms a tree because it's gonna go until it hits the base condition, and then once it hits the base condition, it's gonna backtrack, and it's gonna continue to execute from that point. So here, you can imagine that this could potentially be called multiple different times, the fix-up function. And the nodes are going to be red, I think. So they are always red in the beginning when you add through here, because it recurses and then hits the base case, then it returns red, then continues executing from either one of the branches. So either is gonna hit this, or obviously it's gonna find a node that has the exact same value. Let's say, for example, you have a node on the tree that has 10 as the element, then it's not gonna go to the base case because it's gonna hit the same node basically, so I should duplicate. Alright, cleaning. Yeah, so rotation is very confusing. Like I remember roughly from the concept level, like basically it's kind of hard to about like being able to draw in a easier way. But basically one of the nodes is gonna like become the child of the other node after the rotation. I'm not sure how to explain this like without drawing anything. It's kind of like you pull one node to the right, the other one goes up, and then if they have children, you have to like, kind of like teleport the. You have to teleport the child of one of the nodes because otherwise you would have 3 children. So you pass it to the other side from the child node. If that makes sense. I don't remember very well which one. Hmm. I don't remember really well. See if I can find like a GIF or something. I don't remember which one teleports the node. I think it's the one that becomes the new parent. Uh, Reasons. This one maybe so good. But it's not very good. That's not what I was thinking. This one is just changing the color. Yeah, I think this one maybe. Yeah, so when you rotate P, so it's the parent one. Then you would have 3 children because you would have G as the child. So you need to pass the T3 to the G node. That. And this is, I think, from what I remember, this is the hardest type of rotation to implement. Obviously, here you're just gonna check for the color. Let's see. This is if the right is red and the left is black. Left black. Don't remember really well what the rules are. I think that one of the rules is that the root house always should be black, and there always needs to be the same amounts of black from top to bottom on the height. And I think red, uh, the leaf nodes are always red or something like that. So the right becomes the root. Is rotating to the left. So the right becomes the, it would be like this node becomes the root. Then the one from the left becomes the right. The previous node. Not sure if this is the same situation here that I was talking about here. It's very confusing to think about. But it would be like same situation but on the other direction, I think. So this T3 here will be this. So the left of the new one, the previous one right is updated to be the left of the, basically swapping. Now the right child becomes the parent, and the old left becomes the right of the. It's very hard to visualize. Not really sure. Objects were always confusing to me because like the difference between the pointer and value was also like very hard to visualize what is going on. Like it seems that it is swapping the values of this node because this one would be the left. No, like the left becomes the parent, but then the right of the left. Oh no, is yeah, I'm confusing because it's two levels, I think. I'm not really sure. Yeah, because this one is the left. It's kind of going like in not sure how to say that in English. This one is the left of the previous one. The right from the left. Yeah, I think that it is this thing is the swap here that I thought that I just talked about that is complicated. So I think that the yeah, on this example here, this node here would be the T3 there, I think. Let's see, like this is the left. Let's see here. So the node would be the G, I think. On the left would be the P. And the right from the left is the T3. The node would be the P. Yeah, so this node left here is the T3. That's why it's confusing. Because that's the rotation I was talking about there before. And then the right of the previous left. Right of the previous left. The right, the P was the node. For the P or the S. It's not the same because it updated the value here. I'm thinking that on this case, the node here would be G. Left is P. Just changing the pointer. P is gonna become the neural root. It's T3. So far, I think it makes sense. So G has T3 here. And the node will be the yeah. So that's what's happening because P is the new root here. The right of P is the node, which is G. Yeah, I think it makes sense. I think I understand fine. The part that is complicated and is confusing is the second line here. Because this, I was thinking that they are on the same level, but they are not. So this new root right here is the two levels down. Because this one is on the left, obviously. It's gonna be like the grandchild of the original one on the right. So this new, on this example that I'm using there, to get a reference, this one on the right would be the T3 here, I think. Yeah, because the node is the G, the left one is the P, and then the right of the left is the T3. Then this becomes the left of the G, which is correct here. Yeah, makes sense. And then it's flipping the colors to rebalance, I think. That's why he's doing the new root. There's node color. Yeah, so here on this last step here, on this case, the new root swaps to go to become the color of the old one. On the right, no, the old color becomes red. So. And then the previous one. I think that it does make sense. And finally you get it. And then obviously this one is just symmetrical, just the other way. The thing that makes it even more confusing is that he's obviously calling this on the other one that is running after the backtrack. That's what makes it very hard to understand. This one, it is like going backwards on the function. So here, it's gonna call this a bunch of times when it's backtracking. So hits the base case, then continues to execute. Then as it's going up again through the stack, it's gonna call this. And then each node is like gonna do a local rebalancing on the tree. Not sure why it does this. I think it's checking the grandchild again. Check to see if the left is red. Then from the left node, it checks the left again. It's checking 2 levels. I think that's why it's doing this. Yeah, so if you have 2 consecutive reds on the left, then it rotates to the right to balance. That makes sense. So I think I understand this. It's obviously gonna rotate because you can't have 2 consecutive reds. If they both are red, you just flip the colors. Probably just swapping. So just flips here. And it has the left. It flips the color of both left and right. The only thing that maybe is a little bit unclear is why. I think that's what they were saying. Like the reason why you only have this check here is because of the type of the tree that it is left, left, right, red, black tree. I think so. It only checks for left and left. That's what they were saying there before. That's why there's only one condition there. I think I understand. No. Let's see if I probably watch videos about this later. So this is what the agents were complaining as well, that this function is recursive and then it risks getting Stack Overflow. But I think they were saying they were talking about the drop function, not this one. Yeah, I'm not gonna spend too much time on the drop. I think I should only spend enough time to check that the solution is correct and not so much to dive too deep into each one, because then I spend too much time on each one and there's 54, so it's gonna take forever. Probably after like a couple of like 2 or more, I'm just gonna go a lot faster. It's probably the easiest way is to just quickly check, then see if the LLMs try to compile the actual solution to see if it works. And then if it works, then I just leave it as part of the exercise, because I'm probably gonna do like a baseline of 1 hour probably, or 2 hours. Trying to do this exercise every day. Then it becomes kind of like a ritual, and on the beginning it's gonna be part of the ritual to check, verify that the solution is correct, and then it frees up time to do other stuff. And so this drop here, so in Rust, when you assign a variable to a type or to an object, as soon as it goes out of scope, it's gonna drop the value, and then you can determine how you're gonna drop by implementing this drop trait here. So whenever you implement this, you're telling Rust how to drop the value, how to delete the memory once the object goes out of scope. And I think that this is the part that they were complaining, probably. We're not really sure. It does seems like it's iterating here. But I think that the LLMs were saying that uses recursion is bad. Not sure they are hallucinating, because it seems like it is iterating there. Maybe they were talking about the delete function and not the drop function. Hmm. It looks like it's just compiling now. There's still this true. I think it's just the Rust analyzer probably. Sometimes. Yeah. That's weird. So I'm just gonna read the responses now, and I'm gonna check what it is the error about and see if I have to change something. If not, I'm probably gonna move on to the next exercise. I remove this, what's going on? Maybe if I remove the clone from the implementation, because before I didn't have this. Maybe that's what it's saying. Yeah. So this is the issue. He's just complaining about the T here, maybe. Hmm. Sure, where I should put this. Where? Like, I think that's the compiler is complaining because it doesn't know, like it can't verify that the left and right nodes are types that implement the ORD type. But I don't know like how to solve this. Because they should be coming from the node here. And it should be the type that we have there. It should be this type here. But I guess here it doesn't. I think this is the problem. If I do this, I think that it causes other problems. Yeah. Because then I would have to put here as well. I think I have to change everything. Yeah. Probably not a good solution. Maybe if I do this here. Uh, but I think that ChatGPT doesn't like this. Because it forces you to implement only use types that support this ORD thing here. It's kind of like a hack that the agent found to simplify the algorithm. But I have no idea because I didn't spend time studying this one. I don't know. I think what ChatGPT is saying is that I should implement a function that extracts the node from the tree instead of just returning the minimum. But I'm not really sure like how. I think it would force me to change everything here. Then it would be a lot harder to do. But I think when you delete a node, you have to rebalance the tree, and that's what they're doing here. So it's recursive. It's probably super complicated to understand as well. Okay, so kind of hard to read because it keeps the code blocks. Yes, it could be potentially any type, but it has to satisfy the ORD functionality. That should be some type that at least implements the ORD. It doesn't force should be only ORD type. Not only the ORD type is whatever type that also implements ORD. That's how I'm reading this. As long as it implements the trait ORD. Makes sense. So what ChatGPT is recommending me to do is to create another implementation that doesn't constrain to ORs and then put the isRad function there. The hardest part here, determining how much time to spend on each one. That's the problem. I don't want to spend too much time. But I think that red black trees are used a lot. So it might be worth it to spend more time on this. But the issue is, I think that maybe after I try to reconstruct a bunch of times, I'm gonna be able to intuitively grasp. I think it's just a very hard thing to just know intuitively off the top of your head how to implement. Yeah, it's this one. I'm not sure ChatGPT is telling me to do this. I do. Remove from here. This. Yeah, I think that's the solution that ChatGPT recommends. Is to have the clone problem. I think that is probably the best compromise is just to ask the solution. I'm gonna ask to. I'm gonna ask. Think about. I think I'm gonna ask for the solution for ChatGPT. Then I'm gonna ask for a prompt that allows me to send to the other two LLMs, to Grok and to Gemini. and then see like what their perspective on the same thing. I'm gonna ask to explain the algorithm first. The problem is that this one uses all the other ones. That's why very hard to. I think this is for deleting a specific element from the tree. It's probably delete short for delete recursive that the agents created. And probably the API is this one, yeah. So this one is the internal one, and this is the one you call from the API. So when you want to delete an element, you just pass the element. Just to see if it contains the elements. Both children of the fruit are black. I think this is for rebalancing later, probably. Then it sends the root to the recursive function. Gonna return the new root, probably. Update the color. Yeah, I'm pretty sure that it changes the if both children of the roots are black, then it changes to red in order to force rebalancing later, I think. On the because we're gonna call fix up here, which is the same one that it calls on the when it inserts. And this is gonna on the backtrack is gonna do local rotations to rebalance the tree. I think so I'm not gonna spend too much time trying to understand everything. I'm just gonna ask ChatGPT to explain. And I'm gonna spend more time off stream trying to figure out or trying to understand more in depth how it works. I'm gonna stop here. So probably next time I'm I think I'm gonna not sure how long it's gonna take to finish everything. I'm gonna do like probably 2 or 3 more. Maybe this 3 here where I'm gonna go very slow still to try to learn as much as possible in each one. But then I'm gonna have to accelerate as much as possible to get all of them done quickly. So yeah, it's probably gonna take a couple of days, I think, still. Even if I go very fast, one by one. So either I'm gonna continue to finish this list next time that I stream, or I'm going to study the Rust. I want to study the Rust repository already cloned locally. So either I'm gonna study the Rust C or the entire Rust repository to understand how the compiler thinks about the language. Either that, or I'm going to continue to convert micrograd from Python to Rust. I'll probably do both things as well at the same time, concurrently. So yeah, so see you next time.